YouTube, welcome back to Intuition. In today's video, I'm going to be discussing SAT subject chemistry test. Alright, so for those of you who are in high school, if you plan on being a science major, I hope that you're taking this exam. There's no reason why you shouldn't be, okay? Especially if you plan to be a science major. So you should definitely be taking as many AP classes as you can, and you should be taking as many of the subject tests as you can, because this would actually save you some money on tuition. You know, you'll be able to opt out of taking freshman chemistry or freshman physics or freshman mathematics if you take these subject tests and do well on them. Okay. Today I'm going to be going over some questions like I always do. Let's dive right into it. Question number 1. Let's go. So question number 1 states, all of the following, when added to water, will produce an electrolyte solution except, okay, so should be a very simple question for you guys. It's just asking, if I take this chemical and I put it in water, it's going to give me electrolyte solution. So what's an electrolyte solution? Electrolyte solution is just a solution with negative and positive charges. So it's called electrolyte because it can carry electricity. Okay, that's an easy way to remember what an electrolytic solution is. All we need to do is look for which chemicals is going to give us dissociate into positive and negative charges. Well, we know that there are 2 types of chemicals that will give us positive and negative charges when it dissolves in solution in water, right? One would be salts, like sodium chloride. Potassium chloride. A salt is made up of what? An anion, which has a negative charge, and a cation, which has a positive charge, combined together. And when you put them in solution, they dissociate and gives you plus and negative charges, and that is an electrolytic solution. What's the other type of chemical that would give you positive and negative charges when dissolved in solution? Well, those would be your acids and your bases, right? Like your potassium hydroxide, right? Your hydrochloric acid, right? So these bases and acids, when they get into solution, the hydrogen dissociates, or the hydroxide will dissociate, and the hydroxide will have a negative charge. The hydrogen will have a positive charge, right? And these will give you an electrolytic solution as well. So it's pretty straightforward. Just look at the answers and let's see which one will give you positive and negative charges. Let's look at answer A. Answer A, it's just nitrogen, N2, nitrogen. So is that a base? No. Is that an acid? No. Is it a salt? No, because those 2 nitrogens are bound together through covalent bond, not through ionic bond. So it's not a salt. Right away, that one stands out, and I'm pretty sure that's the answer. So we'll go with that one. But to be thorough, we go through the other answer choices, right? So looking at choice B, HCl. Well, what is HCl? That's hydrochloric acid, right? But in this case, it's a gas. But when it dissolves in solution, it will give you hydrochloric acid. Choice C is potassium hydroxide. What is that? That's a strong base, right? Has a hydroxide linked to a metal. When that dissolves in solution, the potassium will give you a positive charge. The hydroxide will give you a negative charge. That will definitely give you an electrolytic solution, and that is not the answer. Going on to D. D is sodium iodine. That will be a salt, because we know that sodium carries a positive charge. Iodine is a halogen, which means that it's one step away from a noble gas. That one likes to carry an electron, so when that dissolves in solution, the iodine will have a negative charge. That's also an electrolytic solution. That's not the answer. And finally, we have E, which is calcium chloride. That's another salt. The calcium will carry a positive charge. Chloride will have a negative charge. That will also give you an electrolytic solution. That's not the answer. Our answer is A. All right? Easy. Okay, so let's try another one. Let's move on to question number 2. This is I actually like this question because there's some math involved in this one, so these tend to be my favorite. All right, so let's take a look at this question. What does it say? It says, an ideal gas has a volume of 10 liters at 20 degrees Celsius and a pressure of 750 millimeters of mercury. Which of the following expressions is needed to determine the volume of the same amount of gas at standard temperature and pressure? Okay, All right, so we're dealing with gas here, right? And we're dealing with a gas and we're talking about pressure and temperature. What equation comes to mind, right? And it says an ideal gas. What's the equation for an ideal gas? Well, you should know this right off the top of your head. What is that? That's PV equals N RT. Pressure times volume is equal to the number of moles of molecule, right? Times R. What's that? That's let me see. Been a while since I've taken chemistry, but I remember this equation. What was R? Boltzmann? No, R is not Boltzmann. Kent. What is that? A gas constant, right? And T, the temperature. So pressure times volume equals the number of moles times R times temperature. Okay. Now we know what we're given the pressure. We're given the pressure and we're given the volume of this gas at a specific temperature, right? And then what are we going to do? We're going to change the pressure and we're going to change the temperature. Once we change the pressure and the temperature, how does our volume change? We're going to be solving for the volume. So we're going to do some algebra, isolate the volume. And so how do we isolate the volume? Well, we just divide both sides by P, right? Just divide this by P. Divide that by P. On this left side, the P's cancel. I get V equals nRT over P. Okay. For the initial conditions of the gas, what was V? V was 10 liters. What was N? I don't know what N was. They did not tell us what N was, so I'm just gonna write N. R is a constant. T was what? 20 degrees Celsius, right? But when it comes to this equation, was it derived for Celsius? No, right? Derived for Kelvin. So we have to convert the 20 degrees Celsius to Kelvin. Well, how do we do that? Well, it's just 273 approximately plus C. So whatever your temperature in Celsius is, you just add 273 to it. And that becomes your temperature. That becomes your temperature in Kelvin. Okay. So in this case, it was 20 degrees Celsius. So what is that? That would be 293 Kelvin. Okay. Divided by pressure, 750 millimeters of mercury. Okay. Now what are we trying to do? We're trying to find our new volume. We're trying to find our new volume when for the same N will stay the same. This N here will equal this N here. R is just a constant. It's the same R. And then standard temperature is 0 degrees Celsius, which is basically what? The freezing point of water. And remember, if I put 0 in for Celsius, I just get 273. So that's 273 Kelvin. Okay, and then divided by standard pressure. You must know standard pressure we define. How do we define standard pressure? As 1 atmosphere. 1 atmosphere. 1 atmosphere is equal to 760 millimeters of mercury. You must know that. Write it down. In fact, I'll write it down for you. 1 atmosphere is equal to 760. Okay? Know it. And that's standard pressure. Okay, so I'm going to put 760 here. Okay, how can I get the V now? Well, I have two equations. R is a constant, so I have two unknowns, and I have two equations. All right, N is an unknown, and volume is an unknown, right? But I have two equations. I have one here, and I have my second equation here. Now, for this, I'm just going to do some algebra. Pretty easy to do. I am just going to divide the two equations by each other. I'm going to divide equation 2 by equation 1. So I'm going to divide left side. So left side divided by left side, right side divided by right side. So on the left side here, I have V. On the left side here, I have 10 liters. So I'm going to divide V divided by 10 liters. Okay, that's my left side. What's my right side? My right side is NR, which is 273 NR. Divided by 760 mercury. And I'm going to divide this by this, right? Which is 293 NR divided by okay. Then I'm just going to simplify the right side. I'm going to simplify the right side, so I'll bring it up. I'll bring it up here. So on the left side, I'll still have V over 10 liters, which will equal 273 NR times 750 millimeters of mercury divided by 293 NR times 760 . Okay, to solve for V, we just multiply both sides by 10 liters. So my answer ends up being V equals 10 liters times 273. Also, the NRs here cancel with this one, right? Those two NRs cancel, right? So I just get 273 over 293. And also, I just want the number, so I'm going to drop the units, right? So I'll just get rid of that. I'll get rid of the L. Okay, so I get 10 times 273 over 293 times 750 over 760. What's my answer? My answer is E. Okay. And that's how you do this problem.